this video, we are going to explore titration, and the supporting topics that it would be useful to know before you watch this would be a good understanding of what neutralization reactions are, how to work with molarity, and unit conversions, and then some knowledge of acids and bases I would add as well. When do we use titration? Well, it's when we have some kind of solution that we don't know the concentration of. And so we can imagine we have a flask that has a sample of some liquid in it, and we might consider that that was some kind of acid, and let's just call it generic acid. And so we've got some acid running around in our water, but we don't know the concentration, so we're question mark molarity, but we do know generally the volume. And we know that acids and bases react with each other in a neutralization reaction. And so if I have some acid, I could react it with a base. Make this base up here. And if I know the molarity of my base, and I know how much base I need to add to completely react with all the acid, then I could figure out the concentration of my acid. And that's what's called a titration. So this skinny piece of glassware that I've got here is called a burette, and it would drop droplets of base into my acid solution, and eventually it would neutralize them. Now, if I had a purple marker, this would be great, because I could turn my red and my blue into purple, but I don't. But once all the molecules of acid were reacted with, if I have an indicator in the solution, we know that the pH is changing, right? I started with an acid and the pH is acidic, so it's below 7. And as I add base, the solution is becoming more and more neutral until the point at which I've reacted all the acid with the base that I've added, in which case then my pH should be 7. So if I have an indicator that changes color as that pH is changing, it might flip colors. For instance, phenolphthalein is a common indicator. It goes from clear or colorless to pink once the base is all added and the acid is all reacted. And at that point I could stop adding base, and so I would have a known amount of base. So I'd have a known volume as well. So basically, we use titration to figure out the concentrations of acids or bases after doing a neutralization reaction. There are 4 steps in solving one of these problems. First, because you've got that neutralization reaction occurring, you want to make sure you write out and balance the chemical reaction. And second, you're going to want to eventually figure out the moles of the substance that is known. So for a titration, generally we know the molarity and we know the volume of one of the substances, and we can use that information to calculate moles of that substance. Then we can use the balanced chemical reaction coefficients to go from moles of that substance that we had moles of to moles of the substance that we're interested in the problem. And finally, our last step will be to calculate whatever amount or unit has been required for in the problem. So let's do an example. I have 35 milliliters of sodium hydroxide that are titrated with 117.0 milliliters of 0.015 molar sulfuric acid. So that word titrated is just telling me that I've got a reaction occurring between an acid and a base, and I'm trying to figure out some information about one of them. In this question, I want to know the concentration or the molarity of the sodium hydroxide. So my first step is going to be to write out and balance my chemical reaction. We know that this is a neutralization reaction because I have a hydroxide-containing base reacting with an acid, and we know that neutralization reactions always produce water and a salt. And in this case, my salt is sodium sulfate. Neutralization reactions are also just another form of double replacement reactions. I need to balance my reaction, and that takes care of step 1. Step 2 is to go back and read the problem and see that I have 117 milliliters of 0.015 molar sulfuric acid. So I have both a volume and a molarity for that, and I can use my information there to change from volume to moles of sulfuric acid. And I'm going to abbreviate sulfuric acid just SA because my pen's kind of fat here and I don't want to take up too much space. So first step when we're thinking with molarity is to get out of milliliters into liters, and then I can use the fact that I know that there's 1 liter per 0.015 moles of SA, sulfuric acid. I'm in moles of sulfuric acid, but really I want to know about sodium hydroxide, so I can check my ratio here and see there's 2 moles of sodium hydroxide for every 1 mole of sulfuric acid. So 1 mole of SA to 2 moles of sodium hydroxide. That takes me to moles of the thing that I'm interested in. And finally, I need to consult the problem. It's asking me for molarity. Molarity, remember, is equal to moles over liters. So right now, in my equation here, I've gotten rid of milliliters and liters, and I've crossed out moles of sulfuric acid, and I have moles of sodium hydroxide. That's what I want for the top of here. And for the bottom, I need liters. Well, it gave me 35 milliliters, and 35 milliliters is 0.035 liters. Just divide by 1,000 milliliters per liter there. So since I want moles per liter, I'm just going to divide by 0.035 liters. And when I'm done, my answer will be 1.0 molar after I've checked my significant figures. Let's look at another example. I have some barium hydroxide that's reacting with HNO3, which is nitric acid. So my first step is to write out and balance the chemical reaction. Again, it's a neutralization reaction, which is another form of double replacement. And I know that I'll have 2 nitrates because nitrate is polyatomic ion with a -1 charge and barium is with a +2 charge. And to balance this, I needed 2 in front of my nitric acid and a 2 in front of the water. I go back and check the problem and see I've been given 100 milliliters of 0.532 nitric acid, so that's where I will start. I'm changing my milliliters to moles, first getting out of milliliters into liters. Using my molarity here in this step to change to moles of nitric acid. I'm just going to abbreviate nitric acid Na. And then I want to go from nitric acid to barium hydroxide because that's what the question is asking me about. And I see I have 2 moles of nitric acid to 1 mole of barium hydroxide. That was my reaction coefficient that we had right there. And my last step will be to use the molarity that I've been given to convert my moles of barium hydroxide to liters. So 0.390 moles of barium hydroxide to 1 liter. And last, to go to milliliters, 1,000 milliliters per liter. And when that's all said and done, I have 67.1 milliliters of barium hydroxide solution.